Hello everyone, welcome to Engineering Archives. Now we're going to look at learning example number 7. This example is another very easy statics problem. It deals with resolving forces into their components. So let's just get started. So all they want us to do is find the magnitude of the resultant force and find its direction from the positive x-axis in the counterclockwise direction. The first thing to do is find the x components of the two forces. The x component for the 600 Newton force is going to be in the positive x direction, and it is going to look like this. So the x component is going to be 600 cos of 3 degrees, while the x component of the 800 Newton force is going to be 0, since the 800 Newton force is perpendicular to the x-axis. So its component is going to be 0, which will give us a total net x component of 600 cos of 30 degrees, and this would give us 519.6 newtons. Now let's do the y components. The y component for the 600 Newton force is going to be downwards in this direction. So 600 sine of 30 degrees, but we need to also put a negative sign because it's pointing downwards, and according to the sign convention that we have chosen for this question, any force pointing downwards would be negative. So negative 600 sine of 30, positive 800 newtons. Since it's pointing upwards, this would give us a total of 500 newtons. Now to get the magnitude of the resultant, all we need to do is apply the formula square root squares of the x and y components whole squared plus 500 whole squared, and this would give us a resultant force of 721.1 newtons. Now finally, to get the direction, all we need to do is draw the vector triangle. So the resultant horizontal x component for the two forces is 519.6 newtons, while the resultant y component is 721.1 newtons. Oh, sorry. The resultant y component is 500 newtons. The resultant is 721.1. This is the angle that we need. Notice that this angle is formed in the counterclockwise direction from the x-axis, since it's in this direction. So to get this angle, simply apply the trigonometric identity tangent of theta. So tan of theta would be equal to 500 divided by 519.6. Theta would be equal to arctan 500 over 519.6. Or we could also write tan inverse. I think this is much neater. And the final value that we get is 43.9 degrees. 43.9 degrees. Thank you very much. This is the simple and easy procedure for this question. See you in the next video.